can get questions, hocam.
Yes.
After this finish. I don't know.
Okay.
Bismillahirrahmanirrahim. Good morning, everybody. One of the primary goals of the Center for Islamic Economic and Finance Research is to promote greater public awareness and understanding of Islamic economics and finance. We try to achieve this through a range of activities, including publications, public lectures, and community engagement. As part of these activities, we have invited Dr. Asad Zaman to deliver a seminar today, and we are deeply grateful that Dr. Zaman accepted our invitation without hesitation. Thank you very much, Dr. Zaman, for joining us.
Ask.
Dr. Zaman is currently working in Akbat University and holds a PhD in economics from Stanford University. During his time there, he studied under some of the most renowned economists of our time, such as Joseph Stiglitz, Kenneth Arrow, and Robert Aumann. His academic journey is notable for its interdisciplinary nature, covering graduate sequences in economics, mathematics, and statistics. And his postdoctoral studies took place at Center for Operation Research and Econometrics in Belgium. Dr. Zaman's outstanding career has included teaching positions at esteemed institutions such as the University of Pennsylvania, Columbia University, and Bilkent University, as well as several leading universities in Pakistan, including Lahore University of Management Sciences and International Islamic University. His work reflects a lifelong dedication to integrating Islamic principles with modern economic thought, particularly through his leadership at the International Institute of Islamic Economics. A prolific scholar, Dr. Zaman has made major contributions to econometrics, Islamic economics, and statistics, and continues to challenge conventional economic theories through his innovative methodologies and extensive publications. Please join me welcoming Dr. Asad Zaman. Thank you much for being here.
Thank you very much. Thank you very much. I'm very happy to be here, and the youth is the future of the Ummah. So I hope that I can ideas about how to carry on the work. So, as I said, there is a previous talk on agent-based modeling, which I delivered in Ankara a few weeks ago, and the link will be shared with you, inshallah. That was the general perspective on why we need, and basically what I said in that talk is that the modern economic theory, which is being taught around the globe, is built on some fundamentally mistaken ideas. One of these ideas is that history does not matter, whereas history and local context is very important. And the other idea is that the approach to economics should be based on mathematical and empirical methods, that it is a collection of universal laws, which is again wrong, and based on the ideas which are central in modern economics are equilibrium and optimization, and both of these are borrowed from 19th century physics, and they are obsolete. So when the Great Depression happened in 1929, Keynes was led to introduce a new kind of theory, that was the Keynesian macroeconomics. And the reason I'm mentioning is that there are many ideas introduced by Keynes, but one of the critical ideas that Keynes introduced was that of complexity. And what is complexity? Complexity is that the sum of the parts does not equal the whole. So you cannot understand the economy by studying all of the individuals separately and then adding it up. You cannot get the supply function of the firms by taking the individual firms and adding up their supply functions. This is complexity, when the system as a whole does not behave like any of the individuals. So this was one of the critical insights of Keynes, and it was rejected by economists later. And so today also, modern economics doesn't have any complexity. So the ideal tool for exploring complexity is the agent-based model, which is one of the reasons why we should be using this. All right, so let me proceed through this lecture. The first thing to understand is that today the Ummah is in a bad shape currently, and many people have given many diagnoses about why this is so. So I won't go into the different diagnoses. There are at least 6 or 7 different groups of thought. But the central battleground is always between knowledge and ignorance. At the time of the first wahi was Iqra, and it said, Allah allama al-insana ma lam ya'lam. So Allah Ta'ala gave mankind knowledge, and that knowledge removed the Jahiliyyah and brought the nur of Islam into existence. And with that nur, mankind made enormous progress. For 1,000 years, Islam was the dominant religion and civilization. But then, for various reasons, there was decline, and decline was again in knowledge. So today also, this problem is knowledge, the central problem that we have today. Instead of looking to the Quran and the intellectual tradition of Islam for guidance, we are looking to the West to solve our problems. And so that is, again, a problem of knowledge. So Jahiliyyah has again enveloped the world. Mankind is in ignorance and darkness. And again, the potential of Islam to bring light to the world is the same as it was 14 centuries ago. So that as a preliminary, the conception of what is a model is very wrong today. And so before we talk about agent-based models, I have to explain what is a model, because what you probably understand from this is not the right concept. So we have to, before starting on explaining what agent-based models are and how they work, we have to explain something about how knowledge has changed over the centuries so that the concept of modeling became misunderstood. So I will give a very, very brief historical review. This history I have in many other lectures explained in much greater detail. But basically, there were centuries of religious wars in Europe between Protestants and Catholics. So all social theory, what is society, how do we build society, it used to be the scholastics. The scholastics built the social theory on the basis of the Bible and Christian thought. This was rejected because the secular thinkers said that building society on the basis of religion leads to wars. So instead, we need to build society without religion. And so once you reject Bible and all of the Christian intellectual tradition, you are faced with a big problem. You have to start building knowledge from zero. So the Enlightenment philosophers who were trying to do this, they said, okay, what we'll do is we'll build knowledge on observations and reason. And we will reject the unseen, God, Qiyamah, Akhirah, Day of Judgment, life after death, jinn, angels, everything that is unseen was rejected. And so Western knowledge, see, Quran begins with Alif Lam Mim Zalikal Kitabul La Rayba Fihi Hudal Muttaqin Alladhina Yu'minuna Bil Ghaib. So believing in the unseen is the fundamental principle. It starts with this is where knowledge starts. Now, the positivist conception of knowledge, which is the dominant principle underlying Western education all around the globe, is allazina yunkiruna bil ghaib. They systematically reject the unseen. So this is a fundamental problem in epistemology, the theory of knowledge. And so this has reflections everywhere: economics, sociology, politics. All of the knowledge built by the West over the past 3 centuries is based on the wrong principles, and therefore it is all defective at the core, and therefore it all needs to be replaced. So we are going to only study one small part, building an econometric model or economic model. So this is what we want to study in terms of agent-based modeling. How does this apply? So the center picture is the reality. There is the observable, which is on top, and then there is the unobservable part of the iceberg, which is under the bottom, which cannot be seen. So we can think of it as the hidden reality, the unobservable, God, angels, etc., that cannot be seen. And then there is the apparent reality, what we can see, that is on the top, on the surface. So now, in the Western epistemology, the model is an attempt to create an artificial version of reality. But what is a good model? A good model is that which matches the appearances. So the nominalist model, which we look for in econometrics, in mathematical models in economics, we want to match the observables, not the underlying structure. So, for example, if you construct a utility theory model, you say, man, you maximize utility, so there is a utility function. Now, we all know that nobody has any utility function. It's very simple. But they say that doesn't matter. What is the hidden reality? What's inside your heart when you're deciding? This is hidden reality. It doesn't matter. It doesn't matter if it's wrong or right. What matters is that if we look at your actions, go and buy things, and we make the data, and if we build a utility function which matches what we can see you do, then we are done. So that is the nominalist model. Nominalist refers to names. Names are the appearances. So the distinction is between nominalist versus realist. So the real model is also a model. Both sides make models. Both sides simplify reality because reality itself is too complex to be understood. So an agent-based model is a simplification of reality. But the test for a good model on the nominalist view is how well it matches the data. The data is what you can see. And that is the standard methodology. But what we, in a realistic model, in a realist approach, we say that how will it matches the hidden reality? So this is now completely different. Now we say that if the model is utility theory and you say that the person is maximizing utility, so you look at this old woman, she is buying some tomatoes at the store, and you say, okay, can you do you have a function and can you make first order partial derivatives of this function and then calculate the first order conditions? She doesn't even know how to add 50 and 70, so obviously she doesn't know the calculus. So what we are telling about, the theory says about what she is doing is wrong, and it's obvious that it's wrong. But to the nominalist, it doesn't matter. But to the realist, once you say that she doesn't know how to do calculus, then you say that then it is impossible. It's a wrong model. And that matters for our agent-based modeling. Because what we will do is we will put in agents and then we will describe how these agents behave. So we will not have them behave by solving calculus problems. We will give them problems which real people in real world actually solve. And this is not how agent-based modeling is being done in the West mostly, because they test agent-based modeling by assessing the match between the results of the ABM and the data. So we don't want to, that's not our criteria. Our criteria is how well it matches the underneath, the hidden structure. So a model is a guess at the reality, both the observed reality and the unobserved. Uh, Actually, it is hidden mechanisms of nature which generate the observable. So the numbers are not, the nature doesn't produce numbers. There are underlying processes which are going on. So for example, there is a GNP number, but the GNP number is produced by traders who are bringing their goods, farmers who are doing the farming. So this is the real structure. The number is just one number which adds up all of the trades that have been made and says, okay, this is the GNP of Turkey. So that's the observable. But the hidden reality, which is very deep and complex, is the farmers, the producers of cars, and the traders. All of these people are working and they are doing things. So in the agent-based model, we will have farmer agents and we will have trader agents and we will have, because we want to match the real structure. But in the macro model, you just have Y. That's the GNP. What's hidden underneath is not there, and it doesn't matter what is there. So the nominalist model is successful if it matches the data, the numbers match, and the realist model if it matches the structure of hidden reality. So I will give just one illustration of this. So you have data on consumption, investment, and GNP. That is the observable. What is unobservable is the causal relationships. What causes what to happen? So there are many different theories about the determinants. In fact, one of the key battles between the Keynesian demand side economist and the Chicago School supply side economist is on the causal relationships. But causal relationships are always unobservable. You can observe correlations, you can never observe causation. So what that means is that they don't talk about causation, because according to their epistemology, causation is not observable. So yunkiruna bil ghaib, they deny God and they deny causation. They can see only correlation. So once you cannot talk about causation, then you cannot understand why these people are fighting, because neither party, they're fighting over the causal chain, but neither of side mentions the causal chain. So let me just explain. So the supply side model says that the capital and labor, the inputs, determine the the production level. Y is equal to F of KL. I assume everybody is economist, right here? No. Anyway, this is just an illustration. We're not discussing, not going to talking much about that. So the output, the goods produced, depend on the inputs. So that's the supply. So now the goods have been produced. How much will be consumed? Well, a proportion of the GNP is consumption. This is the consumption function. And the remainder, the savings, is the investment. So the savings investment equality. So the government consumes some of this. So there is a government consumption. So the consumption goods are divided into the private consumption and the government consumption. And similarly, the investment goods are divided into private investment and government investment. So in this model, if the government increases its investments, what's going to happen? The goods have already been produced. Then this is what's called crowding out. The government investment plus private investment equals the total investment. Total investment has already happened because that's the supply side. So the only way the government investment can affect is if the government increases investment, then the private investment will go down and there will be no difference in the GOP. So this is the basic argument of the supply side. As opposed to this, what the Keynesians say is that if the government increases its investment or its consumption, what will happen is that the GNP will go up. So the supply side will say this is nonsense. And you can actually find this debate in many top-ranking leading economists having this conversation, that one side says what you're saying is nonsense, and the other side is saying what you're saying is nonsense. And neither side has the correct, they're not discussing the argument correctly. They're not explaining that I think that the causal relationship goes this way, you think that the causal relationship goes the other way. So let's try to find out which direction the causal relationship goes, because that's not part of the discourse. You can't talk about causality because causality is not there, it's hidden. So in the Keynesian model, there is a demand, there is an anticipated demand. The producers, when they start producing, they have capital which is fixed, but the labor is variable. They can hire any amount of labor up to full employment. So how much will they hire? Well, first they think about how much demand is there for my good. And so depending on the demand, then if they think that there is going to be too little demand, they will produce less. If they think there is going to be a lot of demand, then they produce the maximum. So they have an anticipated demand for consumption and an anticipated demand for investment, and that is the sum of those. And so if the anticipated investment demand that they think they're going to see goes up, then they will increase their production, and they will increase their production by hiring more labor. So that's the basic. So if by government intervention you can get to full employment. And so that's the basic difference. But what I wanted to say was that it's not, I'm not trying to give a lesson in macro here. What I'm trying to say is that the hidden causal relationships are what drive the difference, and the causal relationships are out of the picture in the standard economic theory models. They are not discussed very clearly. Same is true in econometrics, and that is why econometrics models are very confused and very confusing, because they never actually talk about causality, and yet the results that you get are critically dependent on causal assumptions which are hidden. Again, this is a methodological problem. So one can do much better econometrics by explicitly focusing on the causal relationships, but nobody knows how to do that correctly. So what is a model? A model is a map of the underlying realities. It connects the hidden variables to the observables, and it describes the causal relationships also, that changing this will cause a change in that. So if X is the causal factor for Y, changing values of X will change values of Y. So one of the essential critical elements of models is that it allows you to study alternative scenarios. What would have happened if, instead of doing policy X, the government had done policy Y? Now, this is a problem for positivist methodology, because positivists say that you cannot do what if, because the what if is never observable. If we ask what would have happened, the clearest example is the coin flip. The concept of probability is that when I flip a coin, it comes up heads. It could have come up tails. This is the standard natural definition of probability. But this definition you will not find anywhere in the textbooks of probability and statistics. Instead, you have this long and complicated frequency theory definition, which is wrong, because you can never flip a coin infinite number of times. And you have the alternative minority Bayesian definition that is also wrong. That is also based on positivist ideas. So, because positivist methodology prevents you from thinking about what would have happened if something had changed, so the many fundamental concepts in economics, econometrics, probability, statistics remain unclear and confusing. So, for example, this concept of an exogenous variable, nobody knows what it is. You can read many definitions in econometrics and you will never learn, because it has to do with causality, and causality is never mentioned. So the thing is that once you have causal relationships, then you can explore what if. If you say that the Keynesian says that if investment changes, then the demand will go up, and so the unemployment will go down because the producers will produce more. So there's a causal change. So now theoretically one should say that, okay, let's go back in time and change the investment and see what happens. But you can't do that. So then you have to find some substitute experiments, and these are quasi experiments, and there are many other ways to try to think about this question. Agent-based models also offers us a solution. Also, if you look at econometric models, they allow you to because they build in a causal relationship and a causal assumption. So once you write C equals A plus BY, then you can say that if Y changes, what will happen to the consumption. But the problem is that this is implicit. This is built into the equation, but it's not real. If you write C equals A plus BY plus epsilon, you can rewrite the equation mathematically as Y equals 1 over 1 minus A times minus C. And so you can just rewrite the equation putting Y on one side and C on the other side. So mathematically, these two equations are exactly the same. There should be no difference between these two equations. Mathematically, but actually, the causal relationship has changed. In the one equation, when you say C equals A plus BY, you're saying Y causes C. In the other equation, when you put Y on the other side, you're saying C causes Y. So they are completely different equations from the causal relationship. But when I was studying econometrics, I tried to understand why you can't write this. And I asked my teacher, the teacher said, you can't do that, but he couldn't explain why you can't do that. Why? I mean, if you want to estimate a regression equation, you can do it with Y on one side or the other side, and you will get your regression estimates. So why is one way good and the other one bad? It's because of the causality. All right. Now, all right. So the thing is that agent-based models are actually realist models. What we want to do is to model the real structure of economics. And when initially these agent-based models were produced, the economists were very excited, and they thought that they will give us very good results. But when they tried to use them, they found that the results that agent-based models produced are very much counterintuitive. According to the standard theory of economics, what should happen is not what happens in the agent-based model. So as a result, these models became marginalized. So today, you don't find any discussion of agent-based models, even though you can do all of economic theory based on agent-based models. See, if you want to study an economy, the agent-based model is the most natural way of doing it. It's the most easy to understand. So, and this is what we are going to try to show. Suppose that I want to study an economy. Best way to do is to start with a very simple economy. Suppose that I have a small village and they produce wheat. There are 100 laborers. There are 10 landlords. The laborers can find jobs with the landlords. 1 acre of land, you can produce 10 bushels of wheat. You can find this is what an agent-based model does. And so, what are the rules for hiring? Who gets hired? What are the wages? What happens to the wheat? All of these things will be inside your agent-based model. So, obviously, this is the natural way of modeling. Now, instead, what happens in a economic theory model? You say, okay, the output of wheat is Y, and this is a function of the land, how many acres there is, and the number of laborers. So, if there are 10 acres of land and 100 laborers, so we say that there is some function of land and labor which produces the output. Now, this is completely wrong because because this doesn't reflect the structure of reality. This is not how it happens. So there are 10 landlords. You have to have each landlord has his own agent. And now when you do it this way, then you find that you cannot get, the economists thought that they would be able to get F of KL, which is what they say. Okay, let's just aggregate all the land, aggregate all the labor, just look at the total labor and the total lands. But what happens is that not all laborers are the same. There is heterogeneity. Some of the laborers will get hired, some of them will not get hired. Maybe in a realistic model, the wages will be different, the productivities of the laborers will be different, the productivities of the lands will be different. So this model, which captures heterogeneity, will be very realistic. You can actually go to a village and build an agent-based model for that. How much acres of land there, how many people there are, what are they doing? You can build your model. So that's why this is the most natural way of modeling. But it is not being done anywhere. Why? Because when you build such a model, it gives results which are not in conformity with the theory. If you apply standard economic theory, you will not get the same results. You'll get very different results. So economists didn't like that, so then they marginalized it. Just like behavioral economics is marginalized, even though behavioral economics studies the actual behavior of uh, human beings. So they don't use that. The economists don't use behavioral economics. If you look at any micro text all over the world, they're saying what people do is they maximize utility. But people don't maximize utility. That's what behavioral economists have found. The people act emotionally, impulsively. They look at some good and they look at an ad and they grab it. They're not calculating cost and benefit. When they go home, their wife says, "Why did you buy this? This is so expensive. You shouldn't have bought this." It's very irrational behavior. But so this is what happens. But and this is what behavioral economists found. But the economists don't allow that to enter the field. So when we try to build an ABM model, what are we trying to do? If you are a conventional economist, then you're trying to build an ABM model. ABM model can be any kind of model. What you're trying to do is match the outputs, the data. You're given some data about the economy, and your ABM model is good if it reproduces the observed data. But that's a nominalist understanding. What we are trying to do is a realist. Does this model so we build this, we have this village, we look at the amount of land, the number of landlords, the number of laborers, and what we're trying to do is to find a sufficiently good approximation that we can understand roughly what happens in that village. So when we simulate this model, then the results we get should match what actually happens. If that happens, again we are trying to match the observables, because the unobservable, but the goal of the matching the observable is not that a good match is a good model. In econometrics, the best match model is the one which has the highest R squared, because the R squared is the match on the observables. But we are not trying to look at the best match. We're trying to look at the best match to reality. If the match on observable is just an indication of a good match to the reality. So the goal is to get understanding, not really to predict, not to fit. So because of we want to understand, so the first principle of ABM model is to keep the model very simple. Make the model the simplest possible model so that you can understand it. Once you understand the simple model, then you can add more agents. So if you want to model a village, start with a few agents and get some understanding of that, and then make it more complicated gradually so that your understanding evolves step by step. And the goal is to get intuitive understanding. And one of the things that is possible today and was not possible, I mean, this would have been the method economists would have used if computers had been available 1 century ago, or I think 1 century ago would have been enough, because the modern economics was developed in the 1930s. So they didn't have computers in the 1930s. So they used this methodology. They said, okay, let's suppose there's only one agent in the economy. Now that's stupid. There's no one agent. But the thing is that if you put in two, you can't calculate the mathematical formulas. So that's why even today the DSGE model, the dynamic stochastic general equilibrium model, which is currently in use in monetary policy decisions all over the world, this has only one agent. So there was a congressional committee which met to explain why did economists not understand why the global financial crisis happened. So they called for the testimony of many top economists. And so they called in Robert Solow, Nobel Prize winner. He died earlier this year, I think, a few months ago. He was my teacher at MIT. So they called Robert Solow to testify, to explain why economists didn't understand the global financial crisis. He said that today the macroeconomists are using the DSGE model. It has only one agent. The global financial crisis occurred because of fraud. One party was trying to defraud the other party, deceive the other party. One agent cannot deceive himself, so there's no possibility of creating a crisis in this model. So this is the thing, that the mathematics that is being used by economists today all over the world is completely hopelessly inadequate. What we need to do, the kind of model that I'm describing, where there's heterogeneity, there's 100 laborers, 10 landlords, it cannot be done in mathematics. The equations cannot be written. If you try to write down the equations for the economy will run over many pages. So you can't write them. And you can't, if you write them, you wouldn't understand them. So what we do now is we just say, okay, here is the structure of the economy and here are the rules of the game. Give it to the computer and the computer will produce the output. This is what will happen. So because we have the computer, so we can use agent-based models. So now what we will do now, so agent-based model is really not, and people think that you have to learn Python and you have to learn NetLogo, and that's true if you want to do complicated ABM. But agent-based model is really a way of thinking about the economy. It doesn't have to do with Python, it doesn't have to do with NetLogo. So what I'm going to do is to explore a very simple supply and demand model. And this is just an example. What I want to tell you, this is a very exciting opportunity. You can take any textbook, any beginning textbook in economics, and take any model that is discussed and construct an agent-based model, and you will get new and interesting and wonderful results, which you will be able to understand and explain why your result based on ABM is better than the result in the economics textbook, and you will be able to understand it. So this is really very exciting. You have low-hanging fruits in research, and you can produce a lot of research, which will be very important. And I think that urgent task for the day is to build a new textbook of microeconomics and macroeconomics using agent-based models, starting from zero, because the existing textbooks in micro and macro are based on the wrong models. So I'm going to take this is just an illustration of how we can do this. So I'm going to look at the supply and demand model. And if any of you have read Manikiv, so he explains supply and demand in a very student-friendly manner. He says, okay, we have a university, and then there are houses around this university, and then new students are coming in. So there are, let's suppose that there are 100 vacant houses and 100 new students. But as I said, the principle is understanding. So we can get enough understanding by thinking only about 10 houses and 10 students. So there is a university, there are 10 empty houses around this university, and there are 10 new students which are coming into this university. And now we are going to set up a supply and demand model. All right. So basically, the difference between agent-based and Manikiv's will produce the supply function and the demand function, and the individual students are out of the picture. I mean, you don't talk. But here we have Ahmed and Bulut and Kara and so on. Every individual is different, and they have their own lives and personalities and desires and preferences. So that's how the agent-based model goes. We have heterogeneity. Okay, so what we will, so I'll explore what happens in the agent-based model approach to exactly a model which Manikiv is solving in his own way. So we will be able to see the differences. Okay, so first we produce the model in a way which is parallel to what Manikiv is doing, so that we can understand the parallel. If I did it correctly, starting from the agent-based perspective, there would be no match to the textbook, because what really happens in the world doesn't have any match to what is written in the textbook. So I'm going to do it in an artificial way to make it similar so that we can understand. Then we can drop the textbook resemblance. Actually, if I was approaching a non-economist audience or a fresh batch of students who are studying supply and demand for the first time, I wouldn't go through this model because it will look very odd and awkward and artificial. This is not the natural way to think about this problem. But once you have been exposed to supply and demand thinking, then this is the way to set it up. So, all right, so what we have is there are houses, there are 10 houses and there are 10 students. The students have budgets for housing. So one of the students is willing to pay 1,000 rupees per month for the house. He is the richest student. Then the second student has a budget of 900 rupees. And the third student has a budget of 800, and so on. So there are 10 students. One of them has 100 budget, the second has 200 budget, and all the way up to 1,000. Okay, so that's easy to understand. Now there are 10 houses, 10 homeowners, and these owners, they have a minimal demand that they will ready to accept. So one of them says he wants 100, and of course he will take more, but he will not take less. So if somebody offers him 50 rupees, he will not accept. Similarly, so one of them has a minimal offer of 200 and 300 and so on. So you look at the demand and supply model. This is what is in Manikiv. So at the price of 1, there is a demand of 10. All 10 students want to. Now there is an assumption here that all the houses are the same, because you can't work the supply and demand. Now in an agent-based model, we don't have to make that assumption. All of the houses can be different. They can have different sizes, different characteristics. The students can have different desires. They can have different preferences. But we'll omit all that. We'll go with the framework which can match Manikiv. And of course, in real world, all houses are different, unless you have dormitory rooms where they are all the same. But in general, houses are different. So at the price of 1, the demand is 10 and the supply is 0. That's what I'm showing. At the price of 101, to avoid the discreteness, there is a demand of 9. The student who has a budget of 100 is no longer in the market. But 9 of the students who have higher budgets, they are in the market, and only 1 owner is willing to rent his house at this price. So you have this demand curve and supply curve, well known. And so there is an intersection. The intersection will actually be, if you draw it properly, any price between 500 and 600. So let's assume it's 550. We are going to work in increments of 50 to make just things easy. So at the price of 550, 5 of the students, the richest students, are able to rent the houses. 5 of the owners are able to supply the houses. And then this is what happens in equilibrium. So according to Mankiw. So according to Mankiw, the 5 richest students will find the housing, and the 5 homeowners with the smallest rents will find their tenants, and everybody else will go home. So the poorest 5 students, they will go back to their village. They will say to their family that I went to the city to try to study at Ibn Haldun, but not Ibn Haldun. Ibn Haldun gives money to everybody. At Istanbul University, but the housing was too expensive. I didn't have enough money, so I cannot study. I will come home and I will become a farmer. I will not go and become educated. So it's a big loss. So why does now the thing is, anybody can see that that's not the optimal solution. Why don't we just cross match? Let the student with the budget of 100 go to the house of 100. All 10 students can be accommodated, and then everybody will have a different life. Now, according to economic theory, what Mankiw says is this is the optimal solution, the best. The market always produces good results. Here, the market producing a terrible results. 5 students are becoming farmers instead of getting educated. So why? This is a big puzzle. These are the things that happens. Now, can we actually achieve this? Now, what happens? Why does economic theory say that this is what's going to happen? Economic theory makes a prediction. Actually, this prediction is not true. This is not what actually happens in the real world. What actually happens is that, okay, so let me just go to the next slide. So according to economic theory makes a prediction about what will happen. Mankiw actually says this is what will happen. There will be an equilibrium at 550. So why does he say that? What are the rules that he is using? So here are the rules. Full information. Every student knows all of the houses. All of the house owners also know about all of the students' demands. This is obviously unrealistic. The homeowners don't know the budgets. The students usually don't have full information. They walk around the neighborhood and they see if there is a for rent sign. And even if there's not, if they like, they can go and knock and say that I'm a poor student here. Can you give me a room in your house, and so on. So this is what happens in the real world. And in an agent-based model, you can actually do that. You can create a structure which matches to what you think happens in the real world. So there is something which we call microstructure in agent-based modeling. What are the rules of the game? So you can set up the microstructure. So for example, in a net logo model, you can put the houses in different places, and then you can put students in different places, and you can have them walk around, and they will randomly come upon some house, and then they will negotiate with the house. And so the rules of the negotiation can be set up. How will the homeowner negotiate? How will the student negotiate? And what will the outcome be? And all of the students are walking around, and then they will eventually find a house. Or if the negotiation breaks down, then the student gets up and he walks to the next house, and so on. So this is called microstructure. How do you actually yani, bit by bit explain what happens? Now um, in the conventional models, you don't have microstructure. You just have what happens all at once. The Mankiv doesn't explain why 550 equilibrium price will emerge. He just says this is what will happen. So there is a story behind this equilibrium, which is actually a kind of a microstructure. So we can tell this story, and telling this story helps to explain why economists think this equilibrium will emerge. And so you remember that our goal in constructing agent-based models is to understand the world. So one aspect of understanding the world is to understand why do economists think that this is an equilibrium. So to understand that, we have to think of the story that they have in their mind. And so this is the story. This is one of the stories. There are a few other stories. So there is the Walrasian auctioneer story. So we think that there is a student housing office. All the people who are interested in renting houses to students, they come into the office and they put a list that I want to rent to a student. They put a photo of their house and they describe the amenities, and they say I have a stove and a washing machine and so on, and this is my rent demand. And then so the student housing office has a book in which there is all of the houses are listed, and then the students come in and they look through the book and they say, oh, this house looks good for me, I'll go and check it out, and if they find it suitable, then they rent the house. So now the Walrasian auctioneer is, first of all, we insist that there can be only one price. Now this is a very stupid rule, but the equilibrium concept works on this rule. So already we understand that one of the rules of the game is wrong. One of the microstructure rules which is used by Manikiv to get this prediction is wrong. And why does he say that? He says, well, let's imagine that all of the houses are identical. So if the houses are identical, then the theory goes that they should sell at the same price. But even that part we know is wrong. We walk around and we see in one store there are tomatoes and he is selling them for 300 TL, and the next door the same tomatoes are being sold for 250, and the next store it's being sold for 275. So we know that the same good does not sell for the same price in reality. So if we are trying to understand reality, then imposing this rule that all of the houses in the neighborhood sell for exactly the same, are rented for exactly the same rent, this is a stupid rule. But remember that in the economists, they're not trying to understand. They're just trying to match the data. So you have statistics, the model that the economists made are just trying to match the aggregate macroeconomic level data. So at that point, this stupid assumption can possibly work. So now the story that is in the mind of the economist says that the student housing office has a manager, and he insists that all of the houses will go at the same price. Why he insists that, we don't know. He's crazy. But anyway, this is the rule of the game. This is part of the microstructure. So he announces a price. He says, okay, the rental will be 350. So all of the homeowners are present in one room, all of the students are present in the other room. And he says, okay, I'm going to set the pricing of housing. Everybody has to give their house at 350, and all of the students can rent houses at 350. There's only going to be one price, because I believe that all houses should be rented at the same price. It is just and fair and equitable. So at this price, then, students 1, 2, and 3 cannot afford. They don't have that budget. So 7 of the students say, okay, I'm ready to rent at this price. And 3 of the homeowners raise their hands that, okay, we are ready to rent our houses. They have 100, 200, and 300 as demand. So the housing officer looks, oh, there are 7 students who want houses. only 3 owners who want to rent, so we'd have no equilibrium. He said, okay, let's raise the price because we want more supply and want less demand. So eventually, when he gets to 550, he will see that there are 5 students who want houses and 5 students who want 5 owners who want to rent. He says, okay, now we have equilibrium. 5 of you go home, you will become farmers, you will not get an education, and 5 of the homeowners, you also go home, you will have an empty house. It seems pretty stupid to call this optimal. Yani, all of the houses owner, all of the 10 students, if the if the housing office manager was a smart guy, he would say, okay, we have 10 houses and we have 10 students, and we can cross match. Everyone can get a house, and every owner can get what he wants. Everybody is happy at the end. So that is a much better equilibrium. But what's the wrong with it? All houses are rented at different prices. So there is an ideology involved here, and the ideology has to do with supply and demand pricing. Actually, supply and demand pricing comes from an ideological debate which took place between the Marxists and the capitalists. The Marxists said that the laborers are being exploited by the capitalists, and all of the value of the production that takes place is due to labor. So that's Marxist labor theory of value. So the capitalist gets money and he gives some part of it in wage. Whatever he keeps is actually his exploitation. So the capitalists didn't like this story, and so they created a counter story. They said that there is a supply of labor, and then there's a demand for labor, and then there's an equilibrium wage. And this is something which the market does. Nobody actually personally exploits or not exploits. Everybody is forced to follow this rule. So one of the critical things is that there is a wage. There is a one price for the good. If there are multiple prices, then this story is wrong. Now, there are other ways. Walrasian auctioneer story is the standard, but it's a very, very implausible story. It's possible to create better stories to justify this. And the main story is one of arbitrage and renegotiation. So suppose we have a story in which we allow the transaction to go. At the end, we're going to create a randomized model. We're going to create a plausible model. But let's suppose that in this model, what happens on the first day is that 3 of the students end up, suppose that the price is announced 350, 7 students run around the town and try to find houses, and the owners, the 3 houses are given to 3 of the students, the first who arrive. 4 of the students are left out of the market, even though they could want to rent. So now the way that recontracting works is that the owners, this is announced that, okay, what has happened at the end of today is that these 3 students have found houses, and these 3, thank you, owners are renting, and all the other 7 are out of the market. So now, what recontracting does is that this announcement is not final. So on the second day, the owners can say that, okay, I agreed to this yesterday, but this is cooling off period. and I don't want to go through this with this contract. So I want to break the contract and make a new contract. So once this is part of the rule of the game, then what happens is that the students who are out of the market, they will go to those three houses and say, you have only taken 350, I'm willing to pay you 500 for this house. So now the owners also say that, okay, I will accept your offer. Similarly, the students can also go to the houses which are unoccupied and say, look, I'm willing to pay 1,000 and you are offering at 900, so why don't I make a deal with you? So there are many unexploited trades in the market. So if we allow these trades to go on, then the situation will change. So the story we have in the mind of the economist is that, okay, the 1,000 person goes to the 900 house. He says, I'm giving you 900 for this house. So now everything is, information is public. So the person who is, the house who is selling for 350 says, oh, don't take the house from him at 900. I can give you mine for 600. So he goes to that one. And then, so if you keep on doing all of this, then ultimately the equilibrium price that will emerge is 500, because at that point, there are no no potential trades left in the market. If you match the richest 5 students with the poorest 5 houses, now all of the houses which are out of the market, they have no possibility to trade with anybody, and all of the poorest students, they have no possibility. So everybody is satisfied in some sense. Satisfied in the sense that there is no unexploited opportunities. So the question is this a good story about the world? One of the things that the economists assume without any compunction is that people are ready to break their words. This is not true. If a person has advertised his house as 600 and somebody comes and says, okay, here is 600. Later on, another person comes and says, okay, I'm going to offer you 800. He will say, I'm sorry, I've already signed the paper. I would be happy if you had come earlier, but now I'm committed. I cannot break my word. So this is how people behave. But the economists, they say, no, this is not rational behavior. This is irrational behavior. Why? Well, you know. So the microstructure assumed by the economist, it will work in this world, that when the person with the 800 comes and the person says, okay, you go to hell, I have now found a better offer. And similarly, if everybody acts in this way, greedy, selfish, maximizing, not caring about his word of honor, not caring about anything except making the most amount of money, then actually this outcome can emerge. But is this a realistic model of the world? Now, according to the economists, they don't care about realism. But from the ABM point of view, we want a realistic model. So we agree that this is not a good model. So then the basic supply and demand model, which is the intuition for everything in economics, is wrong. Now we can do better models, try to make more realistic models. So the supply and demand model, one of the critical things is that the set of alternative realities, what possible is all the houses are set to the same price. So basically there are only 10 prices. You can either have the house price 50 or 150 or so on, up to 1,000. This is the range of possible variations. And so you look among these to see which one makes sense. So in the heterogeneous models that we will examine, there are a lot more possibilities. Every house can have different price. So in this set of alternatives, in the set of alternative realities, the 551 is actually the best. So if you imagine from the beginning that there is only one price, and you see what happens at 650 is that only 4 students will find houses, and also at 450 only 4 students, because the only 4 houses are available at that price. At 650 the demand side creates the shortage, and at this 350, so you get the maximum number of trades at 550. So that is one justification for the supply and demand equilibrium. It is actually a good equilibrium if you accept this rule that all houses must sell at the same price. But why should we accept this rule? All right. So what happens in an ABM model if we try to make a more realistic model of the world? So we can have, basically there are two, the critical assumption of which drives the supply and demand is that everything has the same price. So we drop that assumption. Another of the assumptions is full information. See, as soon as any trade takes place, everybody knows about it. So you say that, okay, so this person is trying to rent a house at 900, my house I would be willing to sell at 800. So you go and and zero transactions. You can go and communicate with both parties, and you can say that, look, to the student who is renting at 900, look, why don't you come over here? I'm going to rent my house to you at 800. So that's full information and zero transaction costs. Everybody knows and everybody can communicate and get to the student, and both of these are unrealistic. So what we can do is 10 students randomly walk around in the neighborhood in the net logo model, and the first house that you arrive at, then you negotiate with the owner. If the demand of the owner is less than the student budget or equal to, then there will be a trade. How will the trade take place? Then you have to develop rules of negotiation. But depending on what you're trying to model, you can say, okay, let's leave that, make some fix that. One of the ways to do it is the posted prices model. Owners cannot negotiate. They have to fix a price, sign for rent, and this house is for rent at 800. They can't, depending on who walks in, argue with him that, okay, this is a rich student, I will charge him a big price, and this is a poor student, so let me lower the price. So the owners don't get to negotiate. They have put in the listing in their book, and they said, I have this house available, and it is for 800. Now they have to rent for 800. They can rent for less if they want, but they cannot rent for more. So they don't have the chance to negotiate. So if somebody has listed for 100, he will have to. So then, as long as the student's budget is greater than or equal to the owner price, there will be a contract, and the contract will be at the owner's posted price. Or we can make other rules if you find that that's not realistic. So everything depends on what you're modeling, what you're trying to understand. In some models, we are trying to understand price formation. In other models, we are trying to understand other things. So what you are focused on, that is what you want to develop the most carefully. And what you are taking as a side issue, you let it go. You make rough assumptions. You can't model everything. So you focus on certain things. One of the possibilities is, if you have negotiations, then you just take the midpoint, the student demand and the house owner's demand and the student budget. You just take the halfway point. So that's without the posted prices. That's also one possible model. So this is an ABM model where the agents walk around, and if there's a mismatch, the owner demands more than the student budget, then they both end up unmatched. So that's the end of the first round. Some of the students will match, some of them will not match, and then we start the second round of the game. So the students who are unmatched, they continue walking and they arrive at another house. By the way, in the first game also we can have different rules. So a student is walking and he arrives at the house. The second student also arrives at the same house. So now what will happen? There are many rules. You can say that once a student is negotiating with the owner, the second student cannot enter. He must go away. Or you can say that the one with the higher offer wins, and the other students is just cut out. So whatever you like. So I'm going to try to use Excel spreadsheet to demonstrate some things. So actually in the demonstration one, I wanted to show what we need to get to standard Mankiv equilibrium in one shot. And so I've already discussed this, so I'm not going to put too much effort in it. So we have the students, we can match the students to the houses, and then we have tentative contracts. All of the contracts that are possible, we put them as a possibility, and then we go through all the students all once again and say, okay, this is what's about to happen. Do you want to intervene? So the student says, yes, the price is being settled at 1,000. I'm unmatched. I would like to go in, and price is being settled at 350. I would like to go in and take one of these houses away from one of the students who is only paying 350. And the homeowners also, they get to intervene. So if we start doing all of those interventions, then the equilibrium, Mankiv's equilibrium, will emerge from that process. And actually, I haven't done it, but you can actually do this, and it's probably worth doing to see how this happens. And you make the first round, and then and you go through the students in sequence and ask, what are you going to do? What are you going to do? So student says, okay, I want to go in, and the house number 2 is renting at 350 to student number 7, and I want to go in and talk to house number 2 and say that I want to offer you 450. So this is what I call the microstructure, how things are happening on the ground. So that is what the agent-based model does, and you can create this model and you can actually drive it to Mankiv's equilibrium. So that's something worth doing, because that's being taught to the globe all around the world. You can see how it would happen, and also you can explain why this is not plausible, why this is not a good model of the real world. This is a model which leads to supply and demand equilibrium. This is not how things happen, but because we understand the real world. And so we see that this is an unrealistic model. It requires no honor. Everybody is willing to break their word. So there is Homo economicus. Homo economicus will work in this way. They are cold, callous, and calculating. They maximize their own utility. They don't care about anybody else. They have no honor. And this is the only way to get to the equilibrium. Now, one of the assertions of Mankiv is that this is the best possible outcome. Markets always lead to Pareto efficient outcomes. Nobody can improve upon them. But we can see this is not a good outcome. 5 students have ruined their lives. They are going to be farmers. They could all have become educated and gone on to have brilliant careers, but they could not find, because the market was cruel and cold. So the question is, how do we measure welfare? And how did the economists measure welfare in a way that is wrong? And so there is a measure, consumer surplus. And you can calculate what consumer surplus is, and that is maximized. So there are 2 assumptions. One is that everyone has the same price. But even if you allow different prices, at the equilibrium that I am suggesting and that all of us would agree with, that just cross-match the students, there is zero consumer surplus. So the question is, why is consumer surplus a very good measure? It is not. It is not a good measure of welfare. So then you can ask, why do consumer economists think that this is a good measure? So there are ways to explain that. And that is what we want to do in agent-based models. We want to understand not just the world, but we want to understand economists. Why do they think such crazy thoughts about the world? You can look at transaction costs, what happens. And there is an experiment. There's empirical evidence by David Card, which was published in a book. And what he showed was that if you take minimum wages and you increase them, according to economic theory, unemployment should increase. But actually, in the real world, it decreased. So this was a big puzzle, and actually David Card says that the economists were very angry with me because this didn't support the economic theory results. So now the question is, how can we implement this result in ABM? How can we explain this? How can we understand what happens? So it turns out that if you implement a minimum wage, you eliminate negotiations. Everybody knows what the wage is. So the first person you find, which is an acceptable match, you get the job. If you have varying wages, then you search a lot for the wages. You try to look for the best wage. And this search process will lead to higher unemployment. And you can demonstrate it via ABN model. And one of my students, Maaz, actually has done a PhD thesis, recently completed, in which he built the ABM model, which shows that if you have minimum wage and you increase it, you can get more employment. And this cannot be achieved within conventional economics. So I think we have come to the end of the time. What I was planning to do was to demonstrate all of this on an Excel spreadsheet, but I think I'll stop here. It will take some time to do that. And let me just, I think that it's not worthwhile. It will take actually set up some time. What I was going to do, and I just want to show that what I wanted to show about the Excel spreadsheet is that ABM is a way of thinking about the world. It is not a NetLogo or Python or programming. And so in an Excel sheet, you can put down 10 students in one column and give them the wages. You can put down 10 houses in another column. You can cross-match them. There are many ways. And then you can say, okay, this is my first round. I've cross-matched. This is what happens. And this is what happens at the end of the first round. Then you go on and you say, okay, in the second round, this is what will happen. These 3 students have found their houses. They are out of the market. These 7 students and 7 houses are still in the market. So we cross-match them again. And then we see what happens in this round. And after 2 or 3 rounds, you can do these simulations by hand. And actually, it's better to do it by hand than by programming in NetLogo, because you know exactly what's happening. And the goal is to understand what is happening. If you use NetLogo or Python too early, then you get lost in the programming details and you don't understand what's going on in your own model. And the goal is to understand. So, okay, I think I'll conclude my lecture here. Thank you.
Thank you very much, John. Then we can get some questions. Yeah.
I'm sorry, because I have a class I have to leave. That's why I said
Sure.
just something that came to my mind. And before I say that, Dr. Recep sent his salams to.
Oh, wa alaykum assalam wa rahmatullahi wa barakatuh.
This, I'm not an economist. What came to my mind is I would like to call it unexpected circumstance in economic activity. I don't know what economists will call that. How I can explain that? The example that you gave, the student and the housing. I say another agent enters into the picture and says, okay, I have my zakat and I want to fund some students.
Yes.
So this
Definitely.
What would you say about that?
Definitely, yes. This kind of thing can be easily put into the agent-based models. We are modeling the behavior. So now, in the if you want to reproduce Mankiv's model, then you have to actually make the owners and the students greedy and selfish. So one student is negotiating, the other one comes in and says, no, get rid of him, I'm going to offer more. So this is a very bad kind of behavior, actually prohibited in Islam. If your brothers are negotiating, you can't interfere. That's actually haram, not permitted. But in the agent-based models, so we can build this into the model. What kind of behavior do the students have? We can even have some students who are greedy and selfish, and some who are generous. That's what allowed, and we can have different kinds of behavior. Some students are lazy; they don't serve too much, and some are very hardworking and efficient, and they go around and search a lot. So any kind of behavior you can build, and you can have additional agents. A person who is zakat, a student can walk around and say, okay, I'm about to go back to my village, but I will knock on one door. And so the one door is, he says, look, I only need a little bit more money and I cannot afford. And so then the behavior of that agent is also possible to model. So you can make the model as complex as you like. This is not possible in conventional economic theory. You can't do these kinds of things. So that's why I'm saying ABAism is a new and exciting opportunity. And the reason that it should actually have taken over the world, everybody should be doing this. But the reason it's not is because the economists have hegemony. They don't like heterodox theories. And every ABM is going to produce results which Manika will not like, and which all of his. So when you produce your ABM model, you're not going to be able to have them published in the top journals because the results are going to be against economic ideology. But that's all right. I have a journal, I'll publish it in all your second rank and third rank journals, and we can produce our own journals, and eventually we will leave them behind in the dust. We'll say, oh, we don't want to read this unrealistic crap which is